Hi everyone, I hope your test went well, your Unit 1 test. Now we're going to be starting Unit 2. I'm going to do a review on sections 2.1 through 2.4 all at the same time because this is all review from stuff you should have learned in math last year. So go ahead and take a minute and pause the video to write this down. That ended up being really good timing for pausing the video. There we go. All right, so a couple of essential questions to think about as we're going through this is first, what does the inequality sign actually mean? For example, like how do we see this out in the real world? And then the second is why do we flip the sign when we multiply or divide by a negative number, which we'll get into or I'll explain in class on Thursday, but this is something I want you to think about for the time being. All right, let's go ahead and look at the first example. So go ahead and take a second, pause this video, write down this example. All right, let's look at the graphs and write the inequality that represents it. Now, I want to point out that there's a difference here. There are open circles and there are closed circles, open, closed. And I want to remind you what the difference is when we use an open circle or a closed circle. So I'm going to write that, actually, let me write that in green instead. I'm going to write that over here on this side. So an open circle on your graph is when it looks like that. That is when you have the greater than or less than. What it means is that solution, that number where your circle is not included. So for example here, the number -2 is not included. It could be everything really, really, really close to -2, but the -2 is not actually included. And then the closed circle, as I'm sure you can guess, means that the solution is included. That's when it is greater than or equal to, or less than or equal to. We have that or equal to that comes into play, which is really important. All right, so I want you to take a second, pause your video, and try to write the inequalities for these 4 graphs. All right, let's look at these 4 examples. So this one, it's an open circle, which means it's going to be either a greater than or less than symbol. And the number that I'm looking at is -2. And if it's all the values to the left, it's all the values that are getting smaller. So it's when x is less than -2. All right, and then now it's the same, -2 going to the left, except now it's a closed circle. So that number is now included. So instead of just being less than, now it's going to be less than or equal to. And then now we're going to the right. So we're still at -2 for both of these. But now it's all the values that are bigger. So we're going to have greater than and then greater than or equal to for the open circle and closed circle. All right, next up, go ahead and pause this video real quick to write down these examples. All right, let's get started on example A. So the first thing I'm going to do to get my x by itself, we're going to treat this exactly like the equations when it was an equal sign instead of an inequality. We're going to treat it exactly the same way in terms of how we solve and get the x by itself. So the first thing I'm going to do is subtract 4 from both sides. So now I'm going to have x divided by -2 is greater than -1 minus 4 is -5. Now, I listened to you before when you gave me your feedback on how you prefer to write multiplying both sides by a number. Most of you prefer to write it on both sides instead of just putting brackets around it and writing it multiplied by it once. So I'm going to multiply both sides by -2. So when I do that, It'll cancel out my denominator. Now, because I multiplied both sides by a negative, what has to happen to my sign? Good, it has to flip. So let me go ahead and write that. So now instead of being greater than, my sign is going to flip and now be less than. So that takes care of the solving, but the example still asks us to graph this. So I'm going to draw my number line. Now when I graph this, please don't fill out tons and tons of numbers on this number line. I'm going to put the number 10 because that's the one I'm working with. And I'll put 11 and 9. I'll go one number on each side. Or you could have done 0 and 20, but put something smaller and bigger on the two sides, just so I know you know which way it's supposed to go. All right, now if I were to graph this, will this be an open or closed circle? Good, it's going to be an open circle. And it's all of the values that are less than 10 or smaller than 10. So the numbers that are smaller than 10 is everything going this way. Now I want to point out, I drew my number line like this with my little circle and my line above the graph. That's just to make it easy for you to see where it's going. I'll show you on the next example another way that you can do your graph as well. All right, I want you to go ahead and pause this video and try example B on your own. All right, go ahead and check your answer. Now I want to point out that you divided both sides by 3. So since you divided by a positive number, your inequality sign stays the same direction. Now I'm going to show you on this graph another way you can do it to make sure that you can still easily see where your dot is and what direction it's shaded. So first, open or closed circle. Good, it will be a closed circle. So a closed circle at -3. And it's all the values less than that. All of the values that are smaller than -3. So I did a little bit of a squiggly line instead of just a straight line so that it's easy to tell my arrow is going this direction. That's the way that it's shaded. Now I also want to point out, that for both of these, it was the less than symbol. And notice this looks like an arrow pointing to the left. And both of these graphs are arrows pointing to the left. Now the reason for that is because if your variable is written first, the x and the c, if it's written first, then your inequality sign, then the number, your little graph, your arrow will go whatever direction this inequality is going. That's a fun little trick. But you need to make sure that the variable, the letter, is written first. All right, let's go ahead and try another example. All right, go ahead and take a second to pause this and write this down. All right, so the first one, what is the first thing I'm going to do for example A? Good, I'm going to distribute this 2. So when I distribute the 2, I get 6y minus 4 greater than 6y plus 10. Now I'm going to subtract 6y from both sides. I want to get all the variables over on the left. But when I do that, all of my y's end up canceling out. Now notice all of my y values are gone. So this should bring you back to solving equations, those special cases. No solution, infinite solutions. So is this a true or false statement? -4 is greater than 10. Good. All of you should have answered that this is false. This is a false statement. -4 is not bigger than 10. So because that's false, that means this has no solution. So there is no possible value of y that I could plug in that would make this inequality true. Which means if I were to try to graph this, my graph would have no points and no shading on it because there's no possible answer that works. All right, let's try part B. What do I do first? Good, distribute the 2. So I'm going to have 4x minus 6 less than or equal to 9 plus 4x. Subtract the 4x from both sides to get all the variables on the left, but they canceled again. I'm left with negative 6 is less than or equal to 9. Is that true or false? Good, this is a true statement, which means my answer is infinite solutions. Remember, I abbreviate solutions as SOLNS. Infinite solutions. Another way you might see this written is all real numbers. Or in other words, this symbol where it's a capital R with double lines. You do not need to write both when you do examples like this, but it's just one of those, write it one of those 2 ways. Sorry, I was trying to figure out what I was trying to say there. All right, now I want to add a little title on this. So these were special cases. These were special cases. No solution, infinite solutions. Now, as you can imagine, for infinite solutions, if you were to graph that, it would be the entire number line. Every single number. You could plug in any number you want, and it would always be true. All right, let me pause this real quick. Write down your next example for you. All right, here's your last example. So go ahead and pause this and write it down real quick. All right, so this says your grades on 4 math tests are 79, 85, 86, 88. You want your mean grade to be at least 85. All right, so let's remember, when we see mean grade, that means we want to add up all of our scores and divide it by how many there are. And then when we see at least 85, does that mean 85 or bigger or 85 or smaller? Good, that means 85 or bigger. We want the score of 85 or anything higher than that. So 85, 86, 87, so on. So if it needs to be bigger than 85, that would be greater than 85, but it could also be equal to 85. All right, so let's go ahead and set up our equation. So when we do the mean, this is adding up all of my scores. So 79 plus 85 plus 86 plus 88. But remember, we have this mystery score. What score on your 5th test? I'm going to call this X because we don't know what it is. All divided by the number of scores. So 5 scores greater than or equal to 85. All right, so if we add all of these up, I trust that you're able to add up all these numbers on your calculator, and you would get that this is 338 plus X divided by 5 greater than or equal to 85. All right, now we need to multiply both sides by 5. When I do that, it'll cancel out my denominator. So I will have 338 plus X greater than or equal to 85 times 5 is 425. And then my last step is to divide, or sorry, not divide, subtract 338. So x is greater than or equal to, inequality stays the same because we're just subtracting, 87. All right, now this is asking us for an answer in terms of a word problem. So I'm going to write my answer as a sentence. You need a score of at least 87, which means 87 or higher, on the 5th test. Could be equal to 87, or it could be anything bigger than 87. So we use the word at least to represent that, 87 or bigger. All right, those are the end of your notes. We will be talking about the sections 2.1 through 2.4, all of this review. We will be going over it again in class on Thursday. Have a good rest of your day.